Hi there, how are you today? We are going to be discussing polynomials with an end result of sketching them. Polynomial means many terms, so it's many terms that are held together with addition or subtraction, although you can have something like 6x be considered a polynomial. So before we can actually get into the sketching component, we need to understand a couple little things here. Let's take a look at y equals 2x to the fifth plus 3x squared minus 4x plus 8. Okay, that is a polynomial right there. The things that we need to understand about these polynomials, we need to figure out what the degree is. And we also want to know the sign of the leading coefficient. Understanding these two things, we're going to have a pretty decent idea of really what this looks like. This is a polynomial that is in standard form. When it is in standard form, your degree comes from the highest exponent. So I'm looking at this, my highest exponent here will be 5. So it has a degree of 5, and 5 is an odd number. So it is an odd degree, and its leading coefficient is a positive 2, so its leading coefficient is positive. We'll get into what we're going to be doing with that a little bit later. You could have, let's say, y equals negative 2x to the fifth plus 3. So looking at that, you find your highest exponent in here. It is also 5. Degree 5, that means it is odd. And the leading coefficient is a negative 2, so it is a leading coefficient that is negative. You could have something like this, 2x to the fourth plus 1. Looking here, my highest exponent, my degree is 4, that is even, an even number, and my leading coefficient is positive, so it is positive even. Y equals 9x to the 8th plus 3x plus 1. I mean, I could just continue to make these things up all day long. Looking here, my highest exponent is 8. 8 is an even number, and my leading coefficient would be positive right there. Okay, now let's take a look at something that is the same yet different. Polynomials. Y equals x plus 2 squared, x minus 1, x plus 3 cubed. These polynomials are not in a standard form. These polynomials here are in a factored form. So when we are looking for our degree in a factored form, we do something a little bit different. We add the exponents for my degree. So I'm looking at this, I have 3. There is a magical 1 right here, that invisible 1. 3, 4, 5, 6. This has a degree of 6. 6 is even. And you look here out front. That is a positive 1 that you cannot see right there, so my leading coefficient is positive. We'll do a couple more of these. Y equals x times x plus 4 squared times x minus 5 cubed times x plus 1. So I'm looking at this, I want to add up all my exponents because it is in a factored form. So I have 1, 2, 3, 4, 5, 6, 7. 7 is odd. And I look at my leading coefficient. This x here out front is positive. Leading coefficient is positive, so it is positive odd. Y equals negative 5x squared times x minus 4 cubed times x plus 3 squared. It is in a factored form, so we are going to be adding up all my exponents here. 2, 3, 4, 5, 6, 7. 7 is odd. And this has a leading coefficient of negative 5, so it is odd negative. Y equals negative 2, x plus 3, x minus 4 cubed. So adding up all my exponents here, I get 3, 4, and there is no x right there, so we're not going to be counting that as an exponent. So 3, 4, 4 is even. And that would be negative, so negative and even. Now, looking at all that and understanding your odds and your evens, the degree of it, and the positives and the negatives, that really comes into play. We can kind of use a matrix here to give you a nice visual of that. So degree. We're taking a look at the degree. Degree could be odd. Degree could also be even. Now from that, you can have a positive. You could also have a negative. So looking at this, if we have a positive and it is odd, you want to be thinking about odd in the manner that you would really kind of think about having a cubic. Okay, in odd, you're going to have one end up, you're going to have the other end down, or it could be flipped, kind of looking like that. So if you have an odd degree, whether it is 3, 5, 7, 9, regardless of what that odd number is, if that degree is odd, one tail will be up, one tail will be down. This is what we refer to as end behavior. So the end behavior, the tails of that graph, one is up and one is down. Then you're thinking positive. Okay, so if I have a positive, the right side will be up and the left side will be down. I am right-handed, as you can see, so that one's pretty easy for me to remember. Positive is always the right side for me. So the right side will be up, the left side will be down, and we are going to have some sort of behavior in the middle. We are not quite sure what that is yet, but we are concerned simply with the end behavior of these graphs at this point in time. So now thinking about this, if we are odd, you're going to have one tail up and one tail down, but now we're negative. So the left side is up, and the right side would be down, and then you will have some sort of behavior in the middle there, some ups and downs, and you're going to end up, though, with these two tails right there. Now let's take a look at even. Okay, so if I'm thinking even, I'm thinking of that x squared idea right there, which really gives me a parabola. If it was negative, it would be a parabola opening down. So if it's an even 2, 4, 6, 8, 10, you name it. If it's even, the end behavior, the tails, one will be up and one will be down. Okay, if you're positive, think up. So both of your tails will be up, and then there will be some sort of behavior in the middle right there. Okay, now if you are negative and you are even, well, the even component means that the tails are even with each other, but the negative means that, hey, we are now opening down, the idea right there. So that gives you an idea of the tails, the end behavior. We also now need to look at really the multiplicity of it. What is happening at these roots? So we're going to take a look at some of the previous examples that we've gone through here, and we're going to apply some graphs to those. Let's first start with y equals x plus 2 squared, x minus 1 to the first, x plus 3 cubed. So if I were to take this and I wanted to see where this graph crossed the x-axis, I could do that. I could substitute this graph together with a very specific line, y equals 0. That is my x-axis. And if I do that substitution, I end up with this. 0 equals x plus 2 squared, x minus 1 to the first, x plus 3 cubed. Now applying the zero product property to this, I can take this and I can solve this right here, this factor. So x plus 2 equals 0. Now it's squared, so we would actually be doing this twice, but that is going to result us in the same value, the same root. X equals negative 2 when we solve. Same thing here. X minus 1 equals 0. X equals positive 1. X plus 3 equals 0. X equals negative 3. Now those are your roots. Remember we substituted here, so if you were looking for the points, this point would be negative 2, 0. This would be 1, 0. And this would be negative 3, 0. Now thinking about this, we already did our degree previously. 2, 3, 4, 5, 6. It is 6. 6 is even. And my leading coefficient is positive. So an even positive, you know that both ends of this graph, the tails, are going to be coming up like that, and you're going to have some sort of behavior in the middle. So if we were to come through and look to sketch this graph, you know where it crosses the x-axis now. Negative 2, 0. 1, 0, and negative 3, 0. We also know about the tails. Both ends of this graph are pointing up. So that's where my graph better end up. Now we need to figure out really what is going on through these points. What does this graph act like? So now looking at these roots, if I were to trace this back up here, it is x plus 2 squared. This exponent is very, very, very important. If it's squared, you want to think parabola. It's a double root. So squared, you want to think parabola. So this root right here acts like a parabola at the 0, at the root. So that means it bounces off the x-axis. So as I'm coming down here at this -2, I'm going to have some sort of parabola behavior right there, excuse me. Now looking at this root, 1, 0, x equals 1, this has an exponent of 1. The exponent of 1 reminds me of a line. Think of y equals x. So this is an exponent of 2. This would be an exponent here of 1. Think of a line. So it goes through the x-axis. Okay. So here, at this value of 1, 0, it is going to be going through the x-axis. It will be acting like a line right there, and you're going to see this in action in one quick moment right here. Now let's look at this one. X plus 3 equals 0, giving us x equals -3. Okay, my root right there, 3. An exponent of 3 on something, I am thinking cubic. And a cubic has an inflection point. That's the point where it changes direction, the inflection point at the x-axis. So right there at the x-axis, it is going to act like a cubic. So if I were to figure this out, this will be a cubic because it has an exponent of 3. So as I come down and I hit this, whoop, there's my behavior at that point. It acts like a cubic there at that value. Now at -2, I'm going to be acting like a parabola. So as I come up and I hit this, I need to bounce off this graph right here. There's my bounce, there's my cubic behavior, there's my parabola behavior. Now I'm coming over to this point of +1. That is linear, it has an exponent of 1. So as I hit that, I'm going to blow right through that x-axis. And that is a decent idea of what that graph looks like. It's not very smooth or clean, but that is a generalization of what we're dealing with right here. We'll do a couple more examples of this for you. It gets much, much, much quicker. So y equals x plus 4 squared, x minus 5 cubed, x plus 1 to the first. So looking at this, I'm going to take each one of my roots and set it to 0. X equals 0, great. X plus 4 equals 0, giving me x equals -4. X minus 5 equals 0, giving me x equals 5. X plus 1 equals 0, giving me x equals -1. So right here, those are the roots. That's where my that's where my polynomial crosses the x-axis. Now looking at the exponent here, it is 1. 1 means it will act like a line. Here I have an exponent of 2. That means it will act like a parabola, up or down, just generalization. Here it is 3, so it's going to be acting like a cubic and having an inflection. Here we have an exponent of 1, so I'm thinking line. Now let's find my degree. 1, 2, 3, 4, 5, 6, 7. 7 is odd, and my leading coefficient is positive. So it's odd and it's positive. Okay, so that means that the tails of my graph are now laid down. I also have my roots. So I'm odd and positive. The right side is up, and the left side will be down. Those are the tails of my graph. Now I'm going to come through at 0, -4, +5, and -1. Now you pick a side, and as you hit that, you need to figure out the behavior. So at -4, it acts like a parabola. So if I'm starting down here, as I hit, I need to bounce off that. Then I'll just freeze and figure out what my next play is at -1. -1, I'm acting like a line. So as I come back to this, I need to be a line right there through that x-axis. At 0, I am acting like another line. So as I come back down, I will be going through again, line, line, parabola. And then lastly, at 5, I'm acting like a cubic, so I need to have an inflection point right there. And it changes direction, and then it heads on out. And that is a nice sketch of your graph. We'll do a couple more. All right, so coming through here, when I set this equal to 0, I'm going to take my roots, negative 5x, my factors, and set them all to 0. X minus 4 equals 0, and x plus 3 equals 0. Okay, when we solve this, we're going to divide and then take the root, giving us x equals 0. This would be x equals 4, and x equals negative 3. Trace that back up. That's going to have parabola behavior, cubic, and that would also be a parabola. So coming through to my graph, pardon that, I'm going to be at 0, I will be at a positive 1, 2, 3, 4, and I will be at negative 3. 1, 2, 3. So my degree 2, 3, 4, 5, 6, 7 is odd, and my leading coefficient is negative. So my left side will be up, my right side will be down. Coming through hitting at negative 3, I will bounce and act like a parabola. Hitting at 0, I will also bounce and act like a secondary parabola. And then coming through at 4, I will have inflection cubic behavior. And we shoot on out there. All right, we're going to do one more for you. Let's look at y equals negative 2, x plus 3, x minus 4 cubed. We set all these to 0 when we sub in y equals 0. So negative 2 equals 0, x plus 3 equals 0, and x minus 4 equals 0, giving us nothing there that doesn't make sense. I have x equals negative 3 and x equals 4. My degree, 3, 4. That is even, and it is negative. So I will be looking like a parabola opening down. So we have negative 3, 3, and we have 1, 2, 3, 4. Both are opening down. So as I come up and I hit negative 3, I will have line behavior. And as I hit 4, I will have cubic behavior. Change my direction with that inflection point. And there you go. Those are your graphs. Hope it helps. Thank you.